Ladies and gentlemen, Charles Rousseau, since graduating from the École des Techniques Supérieures in Montreal in 2005, Charles has worked in engineering in Radio Canada. He began his career in the Spectrum Group, where he became the manager in 2011 and specialized in spectrum management. He also served as the vice president of the RABC for several years while participating in numerous national and international frequency management meetings, including attending the ITU's World Radio Conference, WRC 2015, to represent the NABA in 2019. He became the director of the capital projects of transmission at Radio Canada, which includes the Spectrum team. Since then, he's also been managing the distribution engineering team, which is responsible for projects related to the broadcasting of CBC Radio Canada. Charles has always had a strong interest in wireless technology and production methods related to the use of electromagnetic spectrums. Ladies and gentlemen, Charles Rousseau.
Thank you. Thank you. All right. I'm very pleased to be here with you. However, today we're not going to talk about RF. That's not the goal of my presentation. It's gonna get more technical, so there's three sections in that presentation. I want to first share with you the vision, what's and where CBC Radio Canada is going in the future and why. I'm gonna talk to you about, after that, how we are getting ourselves organized, how we are steering the market to achieve what we want to achieve. And then we're gonna get even a layer deeper technologically, because we're broadcasting engineers. We need to speak about some technical details. And we're gonna speak about one of the challenge that we have steered the market with a lot of many great companies, and that we have achieved. And it was at the last IBC in Amsterdam. It was the subject that was on everybody's lips, which is the MXL. So I'm gonna walk you through that. So first, let's talk about why we are talking about DMF today. DMF stands for what? DMF stands for Dynamic Media Facility. How we are getting more agile. How can CBC can be where the public is? For the next years to come, CBC Radio Canada will cease to try to attract people to their platform. Those platforms will remain. JM2TV, it will remain. But we really want to modify ourselves internally to be where the people are. And where the people are. That's a very good question. They're everywhere, right? They're on YouTube, they're all over the net, they're on Facebook, some TikTok, and they're all over those platforms. How can we get there? How can we reach them? This is what we're talking about today. How we're gonna change internally. We're sharing that with you so it can give you ideas. And it can also, you can also take those information. And if you're representing companies, you're here to represent companies, you can take that, and this is where the world is going. So what problem are we trying to resolve? So some of you probably know the new Maison de Radio Canada. It's a full IP broadcast infrastructure, 2110. And we did that in the past, right? E250, 250 Front Street was the first SDI broadcasting center in the world as well. And been there, done that. We're continue to evolving and pushing the industry toward where we think what is needed to remain fully relevant. So there's two key transitions at play. So we want to replace the SDI infrastructure with IP, which is the 2110. And then once that is done, we want to replace dedicated hardware with software. And there's a very good reason for that, which is agility. And this transition, the second one, replacing dedicated hardware with software, leads to more benefits. than the first one. But the first one needs to happen first. You need to be an IP in order to get to the second level, which is software-based production only. So La Nouvelle Maison de Radio-Canada was the first one. The second one is E250. E250 is for the 250 Front Street. We're going to completely transform CBC from inside out. And that building was built one studio, one control room, right? You have a studio, you have a control room attached. You have another studio, you have a control room. It was built like that. And we want to rip that apart and being 100% flexible, everything based on software. And this is what I will walk you through. How are we going to achieve that? What is our vision to achieve that? So, short-term vision, retrofit of Toronto Broadcast Center. We have no crystal ball of what CBC Radio-Canada will need in the future. We don't know what the production's going to do in 5 years from now. It's evolving too fast. It's just going way too fast. And we'll see the pros and cons from hardware to software, but you'll start to understand that there's a lot of advantages going software. So we want to go from a fixed purpose production facility where each studio got his control room, got his equipment. And when you think about that, when we do one step back, you look at the 250 Front Street, there's a lot of equipment that is doing nothing at all for the majority of the day. That studio and that control room is used for the 5 p.m. show. That's it. What is the infrastructure doing the rest of the day? It's running, idling, but doing nothing. And this is what we want to get away from. So we're going to move from fixed purpose production facility to flexible production facility where we can dynamically configure and handle different type of production. The second midterm driver is that we want to be everywhere. We have over the last 20 years, we had shut down some production center in the field. It was too costly. There was tons of equipment. We need a room that big to have a studio, a control room, and everything. It's no longer the case. We want to be story-centric. And now to have field production, you need a camera and a journalist, and that's it. And then the content will be centralized, and it will be story-centric. That content will be reusable by anyone within CBC Radio-Canada for any use in a country. So that's our midterm driver. We want to be much more present in the field, in smaller market. We want to be closer to Canadian citizens. That's the midterm driver for what I'm presenting to you today. So our target solution, flexible production system based on software. So when you compare both hardware and software, flexibility, clearly the advantage is on the side of the software. Fixed purpose device that in some cases are used only part of the time. This is my example about the studio being used just for the show that is running inside that studio, and that's it. Whereas software, our vision is that we will be able to use the same pool of computer to create the multi-viewer, the color corrector, everything we need to run a show, and then free up that those resources back to the system to run the next show that's coming next. Agility, it's not scalable. When we're doing election, oh man, we need a truck, we need 2 trucks, we need 5 other cameras, we need to grow CBC, and we need 24 other EVS channel. Same for Olympics. And we always needed to gear for the worst case scenario. Whereas in software, you just add licenses. It's super fast to adapt and scale as the demand arrives. Agility, it's a long process to buy and install because hardware, you need wire, you need a rack space, you need all of that. But in software, as long as you have a computer servers. Hey, can I try your software? Yes, please. Install it. Done. It's super fast to try, fail, retry, maybe fail again, but it's going fast. System complexity, yes, it's more complex. It's more complex, and today I'm going to try to give you an horizon and what is the infrastructure and the structure looks like. Okay, so what's our vision? So first thing first, you need studio space. That doesn't change. We will need different kind of studio space. So those studio space will remain there. Large one, medium and small, some hit area, just a camera in a corner, and some self-operational space where there's just one person presenting and she or he is able to control everything around it. So that doesn't change. But what will be installed in those spaces, there's no hardware. It's just to capture content. Mics, cameras, intercom. That's it. Nothing else. No other gear. No hardware at all. Then you have the control room that is not necessarily next to the studio. It's somewhere inside the building, but everything is routable to that control room. Any of those large studios can be routed to the same control room. And those control room have screens and whatever you need. If you need a multi-viewer of 6x6, you're going to have it. 12x12, you're going to have it as well. These control room, you'll have the screens, a desk, a GUI for user interface, and some control surfaces. Console, basically. But this is just remote control. Everything happening behind is on the computer. So production space, flexible control, and then comes the hardest part of what we're trying to do. So like I said, you have computer servers where your media function is running on, and all those servers are resources that are pooled together to run what you need to run. So here, on top of that, you have your media function. Video mixer, audio mixer, clip replay, cam shading, color controller, multi-viewer. All of those are simply function. Just like that, right? You have an operating system, you have function, apps that you run. And the challenge for broadcasting is that all of those apps needs to communicate together as fast as possible. And this is where the media exchange fabric is coming into play. We'll talk about that. This is the MXL. It's the media exchange layer. So generic computer infrastructure, on-prem or on cloud, can be on cloud, can be anywhere you want. It's just computer resources and software-based application from multiple vendor. And I repeat, for multiple vendor, this is super important. And of course, on top of that, you have the orchestration layer. We'll talk about it later, but you have this orchestration layer where, okay, at 9 a.m. we have a show, I need this and that and that and that, and then you need to start planning your resources and spin up the application you need just before the show starts. And then when people sit down, they have just what they need to run the show, and after that, those resources are freed up again. Using software for media. Are we there yet? So, some reality check. Limited scale. You are limited by the size of your computer. One media function can only run with what the computer can give you. So if you need more power, you need a video mixer of 64 by 64 or a router. Well, if it doesn't fit one computer, well, you're a bit screwed. So application cannot be larger than what fits in a single servers. Most software solutions are single vendor. That's the case right now that we're trying to fight against. We're trying to steer the industry to be interoperable and works together. high latency, because uncompressed media exchange between apps, it takes time. It's high speed, which leads to high CPU clock, and it creates a lot of latency. So what we do, we compress. But again, compression, you just add more latency. You haven't solved anything. So NDI and SRT, this is very popular right now. It just contributes to add more and more latency. And then feature completeness, well, their current software solution is highly specialized, jack of all trades, but master of none. So using software for media production, how do we make it happen? So what we have done a year ago, we have said to the industry, we went in RFSA, we've said, this is where we're going. CBC Radio-Canada, we're going 100% software for reaching out this agility. So we broadcast the vision, and then we wait for the application to come in, and then we start the analysis of those applications for a very short term, 3 years, contract to start testing the market. And then once we're gonna have tested the market, we're gonna go on the longer term solution. But right now we're only testing. And here's what we discovered. We published 30 different media functions when we did this RFSA to the public. Here's what we're looking for. 30 media apps, 30 different media functions that we want to achieve. 170 media function was proposed and was available right now, 100% software. We were quite impressed by how large it was already in the market. However, there's a total of 12 vendors that answered those 170 media functions. 3 of those 12 vendors proposed their own platform. It's just normal. I'm Lavo, I'm JVM, Grass Valley. Here's my pool of function. Use that. That's what we have. But none of them could work with the other guys. None of them could work. GVM cannot work with Lavo, cannot work with Redel, cannot work with any of those platforms. The media function, you're stuck into that vendor. You're vendor locked in. None of the other 9 vendors support any of the other guys' platform. And that's a problem for us. It's not where we want the business industry to go. So industry awaits clear direction. So these were the companies that we saw answering to our application. And what we can see is that there's some similarity with what we have seen in the pre-2110 standard. There was many proposition, and just here there's many proposition of a platform where you can run software, but there's no interconnection amongst them. So what we done from there? So we said, okay, we need to standardize. We need to bring something solid. We need to organize ourselves. And this is where we sat down with the EBU. And we work with the EBU, we work on a dynamic media facility, reference, and architecture to define what we are looking for. And then I'll show you, I'll dive a little bit into that. We'll look at the workload lifecycle and some of the layer. What we don't want to have is that, right? You have all your modern digital infrastructure that sit on a project, some random person in Nebraska that has been thanklessly maintaining since 2003. You recognize that piece of software in your company, right? We do. We do have some of those at CBC Radio-Canada. And it's normal, it's okay, but how to build that system ground up very solid, this is why we sat down with EBU. So fundamental needs, there's 3 things here that I want to make sure everybody is aware. Interoperable software media function. That's the first one. We don't want to be vendor locked in. We don't want to just have business with one vendor out there. And we're not alone. In fact, the whole market industry is pushing that way. Multi-vendor, scalable, and layered model standard IT tool. We don't want to reinvent the wheel. There's IT tool existing out there. We're going IP. IP is everywhere already. We want to reuse those IT tools and leverage that industry. Let's go a bit in the reference architecture and how that reference architecture from EBU fit our vision and what we are seeing for the next future. That was published, by the way, just before IBC last year. Not this year, but last year. So it's been out for almost a bit more than a year. So what is the workload life cycle of a dynamic media facility? So it's the plan, build, run. Ring a bell, plan, build, run. If you have some capital planning inside your company, you're probably going through that each year. You plan your capital plan. Then you build your capital plan, and after that, you've done the key to operation. Then run the show, run the what we just built for you. It's a bit the same, but it's on steroids, right? It happens super fast. You plan your work, the design and the plan resources. Okay, we have that show. We need that many cameras, that many wireless mics, that many intercom channel, and then you plan your show and you reserve your resources on the computer, on your computer infrastructure. Then the orchestration layer is building everything that you need. You provision the resources from a computer standpoint. You reserve the memory. You do everything that you need, and then you configure your software. The media apps are up and running. Then you run your show. You operate what you just created in some minutes, and after that, you finalize, you review that everything went well, and at all time there's monitoring and update that looks at this circle life cycle. So the layer model is this one. So what I've been showing you here, it's based on the layer model. So we'll not spend too much time on this one, but you see the media function are up there. Media exchange layer is the MXL, it's my next subject. And then you have all the infrastructure, the containerized platform that will handle your software. It's down there. And the vertical layer there, this is the orchestration. This is the orchestration layer. So if you put the reference architecture next to what I showed you previously, you can see where stand where. So of course, the user interface and application are up there. Media function is all the function, all the software, the apps you're going to be using. And the media exchange fabric is the media exchange layer. The bottom part here is your computer, and then comes the orchestration that orchestrates all of that all together. So where we are at. Let's talk about the MXL. There is right now, before MXL exists, there was not a fast way to exchange data between media apps. Each time, let's say you have a computer host, and inside that computer, you have many media functions. You have a color corrector, you have a multi-viewer, then you have an encoder. Each time a media function needs to speak to the other one, even if it's running on the same computer, you have this timing buffer that it needs to speak to. Then you need to stream what's the output of your media function. And then there's a loopback at the NIC card itself. You're almost on the network, but there's a loopback that comes back into your computer. And then there's a stream RX, there's another buffer, and then it's your next media function. All that in a non-compressed environment takes tons of CPU clock, tons of resources from your computer, and it adds a lot of latency. How can we exchange this output to this input without losing all those resources and having close to zero latency? This is what the MXL is resolving. So streaming requires significant CPU resources, so you can be less dense on your computer. Like I said, we use already existing IT, not infrastructure, but technology. Our DMA, that IT is doing that for a long time already. We're just having another layer where the MXL is there. So the MXL is in between the memory and the media function. And what it allows to do is that media function 1 will write into memory, whereas soon as it gets written, media function 2 is able to read that output. And it's also true between computer because we are using the remote memory access in order to accelerate. Even if the media function is not on the same computer, you're gonna still have this rapidity at which you can exchange information. So memory exchange is asynchronous, resulting in much lower latency. And it dramatically reduces load on computer resources because you're saving all those clocks for the buffering and the NIC card loopback and all that is gone. It's just I wrote into memory, the other media application is able to read the memory. So direct memory exchange, it has been achieved by individual vendor. Again, I'm taking those same example, the ones that are working partners that are working with us in that GV, Lavo, Riedel. Some of these guys, they were able to do that direct memory exchange, but you needed to remain in their own application. It wasn't possible between vendors. There was no standardized way of achieving this across multiple vendors. And this is what exactly the open source MXL SDK provides. It's a common method to exchange media amongst vendors. So why an SDK? Time check, 10 minutes, okay. Why an SDK rather than a standard? It's much faster to hit the market. And there's some very popular SDK out there. If you know Chrome, which is Chromium from Google, it is an SDK, one of the famous ones, but there's other examples like that in the market. It is fast. It's a piece of code that you put online. It's under Linux right now, and that any company can go in there and download this piece of code. And the only thing that remains to do is to integrate that piece of code to their own application. So it reduces barrier to entry and development costs for apps developer. It's the modern way to go when you want to have interoperability. It dramatically improves interoperability, indeed, because all the market is using the same piece of software. That is free of charge. You just download the piece of software. So some open source and SDK approaches that have been super successful in our industry. SRT, NDI, we already spoke about those two, but those are SDK, right? And then MUS, the discovery standard, or yeah. So again, when I said we during this presentation, it's not we CBC Radio Canada. We shared our vision with you today, but we're not alone. Really not alone. There's some very big company in that adventure with us that is actually working to develop this SDK, this MXL technology. So the technical steering committee is out there, is on the top here. You see who's involved. So we have the BBC, the EBU, but Riedel, Lavo, AWS, and NVIDIA. They are working with us to have this piece of software working. Requirement Council and other community participants. So there's a lot of big company that is working with us achieving that. So if you are here representing companies, the link to download the SDK is right there. It's free. You click on that, you can download it, and you can start working on it to have that implemented to your software. And hands-on tutorial is also there. That was done in EBU by Mathieu Rochon, one of our colleagues at engineering at CBC. Félix Poulain as well participated. So it's a hands-up just to learn how it works and to play with the SDK. But the SDK is already available. You just need to click on the link, download it, and start the integration. Is it real? Am I just speaking about some unicorn world here? Or not? Right? So, if you go back at NAB 2025, there was one example. It was on the Dell booth on the corner. Very small example. And then 6 months later, at the last IBC, there was all these examples. So 1, 2, 3, 4, 5, 6 examples. But one of them I want to talk to you today is the middle one, Grass Valley and Zoom. Zoom, they're not here, right? They're not nowhere there. Zoom, it's an external partner that look at that and say, oh, that looks interesting. And when you think about Zoom, each single little face in a meeting could be any kind of source, right? It's a camera source. So Zoom, they said, okay, let's try that. So they download the SDK. They have that SDK implemented in matter of weeks. So it took them 3 to 4 weeks to implement that SDK to their platform. And they tested that in matter of hours. So that was very impressive. So all the feeds from Zoom was going into the AMP orchestra, the GVAMP, basically, which is a playout engine. And you have all these sources coming in, uncompressed, with 0 latency. The latency was so short that it was hard to measure. So that was very impressive. And GVM was successfully able to control the Zoom API. So the integration between those two software were done inside a month. That was very impressive because we haven't heard Zoom before. Zoom was not part of the activity into the MXL, and they implemented that very nicely and quite fast, actually. And in fact, once it's done, it's not only GVM that has MXL compatibility. Then Zoom application is all of a sudden compatible with all those guys because Redale has implemented SDK. TVU as well, Net and Live as well. So Zoom now can be compatible with any of those platforms because they're speaking the same language and they can exchange uncompressed media with no latency. So it's evolving quite fast. So what's next? For sure, it will be the orchestration portion. They're starting working group, getting organized. How are we going to orchestrate all that? There's challenges on the horizon, that's for sure. But yeah, this is where the orchestration layer is. And at the end of my presentation, if you want to know a bit more about it, I have regrouped all the papers after the last IBC because there was many interesting papers that came out of last IBC. A light in the tunnel, dynamic media facility and media exchange layer by Mind the Gap. TVB Europe as well was talking about that. The reference is there. My German is not that good, but das Top-Thema der IBC. So the top topic of IBC was the MXL, BBC as well, and Devoncroft at the last NAB. You can recognize here our vision and what we are thinking, how the production will look like in the future. I'm Charles. I'll be around for those 2 days. Feel free to come by, ask any question you might have, want to discuss this. I'm really there to discuss and help you guys. Thank you very much.
Charles, thank you very much.
Good.
We want to thank you on behalf of the CCBE for coming today and giving your
My
presentation. This was one of the papers that I was very interested in, and it's something that's coming along on the lines, and it's coming up in broadcasting. And the fact that I work in television, it's just all that much more interesting. So thank you very much for your paper.
You're welcome.